Tennis balls must rebound approximately 110 centimeters when dropped from 200 centimeters. Soccer balls must rebound approximately 120 centimeters when dropped from 200 centimeters onto a steel plate. Basketballs must rebound 53.5 inches when dropped from 72 inches onto a wooden floor. Squash balls must rebound approximately 29.5 inches when dropped from 100 inches onto a steel plate at 70 degrees Fahrenheit. Okay, so discuss how you can measure a ball's bounciness and which ball listed above is the bounciest. All right, so how do you think we can go about measuring a ball's bounciness, taking this information we've been given? What do you guys think? How could we measure the ball's bounciness from the information we've been given? Okay, so what we can do is we can take the information, and what we'll do is we will put in the rebound height first. So the first one says 111 centimeters when dropped from 200 centimeters. So we take 111 and we divide it by 200. Okay, so that is for the tennis ball. Now let's see what the ratio is for the soccer ball. So the soccer ball goes 120 centimeters when it's dropped from 200 centimeters. So its rebound ratio is 0.6. 0.6 is higher than 0.55. So far the soccer ball is the bounciest. All right, let's figure out what the basketball's rebound ratio is. So it is 53.5 inches when dropped from 72 inches. So 53.5 divided by 72 is 0.743. Okay, 0.743 is higher than 0.6. So now the basketball is the bounciest. Okay, squash balls. Squash balls must rebound 29.5 inches when dropped from 100 inches. So 29.5 divided by 100 equals 0.295. All right, so that one is the least bounciest. All right, so how do we find out which ball, how do we measure a ball's bounciness? We divide the rebound by the height dropped. The basketball is the bounciest. Because it had the highest ratio. Okay, and by the way, bounciest is not a real word. It's supposed to be most bouncy. So anytime you have a word that's too compact, that's two syllables, then it's most bouncy or more bouncy instead of bouncier or bounciest. Okay. All right, on this next page, it has a video for us to watch of what we would be doing in the classroom if we were meeting in person. So this is what we would be doing. Do you have it? Can I have this last piece? Okay. I'm glad I can still taste. That means I don't have to. Not necessarily, because Jenny and I meant to use it, she could take this now. Just had a weird go. Okay. That is a super fun activity. Sorry, if you guys want to do it at your house, you can totally do it. Get a yardstick, get a couple of different kinds of balls, and then see what the ratio is. Okay, does the height from which the ball is dropped depend on the rebound height, or is it the other way around? What do you guys think? Okay, so the ball, the height that it's dropped will depend on the rebound height. So what we can say is we can say that the rebound height will depend on how high you drop the ball. Okay, page 4. Should a graph of rebound height versus starting height be continuous, or or should it be discrete? So continuous is where it's a line, discrete is where it's points. So what do you think? Should it be discrete or continuous? Should it be points or a line? So this one should be continuous because it doesn't matter what height you drop the ball from, and the rebound height can be any amount. And one thing you can think about is you can drop a ball from like 6.5 inches, or you can drop the ball from 36 inches or 25.25 inches. Okay. All right. So on this one, what we're going to do is we're going to solve each equation. Okay, so for this one, what we can do is we can distribute the 2 throughout the equation. So we can take that 2 right there. Oh, holy moly. Why is it that I can't write on that side? I don't get it. Okay, we're going to have to take a break. Hold on. Stop share. And then we're going to come over here, blank. And then we're going to go back and share the screen again. Okay, now we can draw. All right, so we've got 2 times x minus 2. So we'll go 2 times x, that's 2x. 2 times -2 is -4. And that equals -6. So now we're going to solve for x by combining like terms. So we've got the -4 that we can combine with the -6. So we'll add 4 to both sides. So +4 and +4. All right, -6 plus 4 is -2. So 2x equals -2. Now we can divide both sides by 2. And we've got x equals -1. Okay, so that's the answer we put right here. X equals -1. Okay, same thing with this one. We're going to distribute. So we'll distribute the 2 to the x plus 1. 2 times x is 2x. 2 times 1 is 2 plus 3 equals, and then we'll distribute the 3 to the x minus 1. 3 times x is 3x. 3 times -1 is -3. Okay, so we can combine our like terms. We've got on the left side of the equal sign, we have a 2 and a 3. So +2 plus 3, that's a +5. So on the left-hand side, we have 2x plus 5 equals, and on the right-hand side, we have 3x minus 3. All right, so now we're going to continue combining like terms. So I have this x and this x that we're going to combine. And since the 3x is bigger, I'm going to subtract 2x from both sides. So 3x take away 2x is x. And then I'll combine the -3 and the 5. So I'm going to add 3 to both sides. 5 plus 3 is 8. So 8 equals x, or you can type x equals 8. Either way, it's the same. Okay, page 7. Page 7 says, calculate the slope of the line through the points 6, -8, and 3, -4. So if you remember, to find the slope of a line, we just take the difference in the y's and the difference in the x's, and we put them over each other. So the difference in the y's, we have -8, and we have minus a -4. And then the x's are 6 minus 3. Okay, -8, take away a -4. We'll slay the vampires, and that will turn it into a plus. So -8 plus 4 is -4. And 6 take away 3 is 3. So our slope is -4/3. Okay, now we have to write the equation, but we don't know what the y-intercept is. We only know what 2 of the points are and what the slope is. But we can start our equation out. We've got y equals -4/3 x plus b. So we've got a, oops, not equals b, plus b. So we need to figure out what our b is. The way we do that is we take 2 of our points, and I like using the smaller point, so I'm going to use 3, -4, and I plug it into my equation. So for y, it's -4, so I'll say -4 equals -4/3 times x, and the x I'm going to use is 3, so I'll times that by 3, plus b. And now I just solve for b. So -4/3 times 3, that will cancel out our 3's. And I'll have -4 equals -4 plus b. You might know what b is already, but if we want to continue on so we can make sure, get our b alone, we just need to add 4 to both sides. -4 plus 4 is 0, so 0 equals b. And if we come back to our equation right now, we can either put plus 0, or we can say we don't need a plus 0, and we can just delete that and say y equals -4/3 x. Okay, page 8. Page 8 is a duplicate, so skip page 8 and go to page 9. Okay, page 9. Consumer Reports magazine collected data for the fuel efficiency of cars, miles per gallon, compared it to the weight, thousands of pounds. The regression model below was created. Y equals 49 minus 8.4x, and R equals -0.903. Okay, calculate and interpret R squared in context. Okay, so the way that we would calculate R squared is we would take this R right here, R equals -0.903, and we would square it. So we pull up our calculator, and -0.903 squared is 0.815. So we can say r squared, and I'm going to turn it into an equation by clicking this little square root symbol, equals 0.815, which equals 81.5%. And the context is so we can say the heavier the car, well, let's see. Let's go on to the next page. Okay. So we'll just say r squared equals that, and it's how efficient the car is versus how much it weighs. Okay, page 10. Interpret the slope in context. So right here, the slope is negative 8.4. So what does negative 8.4 mean? So a negative slope would mean that the heavier the car is, the less efficient it will be. Okay, page 11. AAA Packages Plus sends packages overnight for $5 plus 25 cents per ounce. United Packages charges $2 plus 35 cents per ounce. Mr. Molinari noticed that his package would cost the same to mail using either service. Write an equation to represent this situation. Okay, how would we write an equation for this? The hint that we can use is that it would cost the same. So that means that it would be equal. So we can take this information and we can set it equal to this information. Okay, so we've got 5 plus 0.25 x, because we don't know how much the package weighs, equals 2 plus 0.35 x. How much does Mr. Molinari's package weigh? Okay, well, we know that if they are equal, we just need to solve for x. So we'll take our equation right here. So go 5 plus 0.25x equals 2 plus 0.35x. And then we'll solve for x. Okay. So we've got to combine like terms. I've got a 5 here and a 2 here. Since the 2 is smaller, I'm going to subtract 2 from both sides. 5 minus 2 is 3. And then the next part we can combine is the x's, 0.25 and 0.35. Since we subtracted the 2 from the other side, we're going to subtract the 0.25 from this side. Okay, so 3 equals 0.35 subtract 0.25 is 0.10 or 0.1x. And now we just need to get our x by itself, so we need to divide both sides by 0.1. And if we pull up our calculator, oh yeah, this calculator didn't want to work. 3 divided by 0.1. Oh, now it's going to work. Now, because I said it wasn't working, it wants to work. So x equals 30. Okay, page 13. Meredith lives 24 blocks from her friend's house. If she travels one block every minute, how many minutes will it take her to reach her friend's house? And what if she travels 2 blocks every minute? Show how you can calculate each answer. Okay, so if Meredith travels that far, 24 blocks, and she goes 1 block every minute, the first thing we could do is we could go, we can go 24 blocks divided by 1, because 1 block every minute equals 24 minutes. So now if she travels 2 blocks every minute, so this next scenario is she travels 2 blocks every minute, so it's 24 divided by 2, which will take her 12 minutes. Okay. Okay, so if we want to fill in our graph, she goes 2 blocks every minute. So by the time she goes 5 minutes, she's up to 10 blocks. By the time she's up to 10 minutes, oh wait, time. She goes opposite way. Hold on. Junk. Time is up and down. Okay, so she goes over 5 blocks. That took her 2.5 minutes. And then she went 10 blocks. That took her 5 minutes. And then she went 15 blocks. That took her 7.5 minutes. And then 20 blocks took her 10 minutes. So there we go. And that's sort of what her line would look like. Shrink. Okay. All right, let's go on to page 14. Now we can fill in the table. The table at left represents the amount of time it would take Meredith to get her friend's house if she traveled at different rates. Okay, so first we're going to say she's going 1 block per minute. So that means it's going to take her 24 minutes to get to her friend's house. Then she goes 2 blocks every minute. So 24 divided by 2 is 12. And then 3 blocks every minute. So 24 divided by 3 is 8. 4 blocks every minute. So 24 divided by 4 is 6. And then 6 blocks every minute. That's going to be 4 blocks or 4 minutes to get to her friend's house. 8 blocks every minute. That'll take her 3 minutes. And then 10, we're going to use our calculator to calculate 10 blocks. So we'll go 24 divided by 10. 24 divided by 10 is 2.4. 2.4 minutes. And then 12 minutes, that will take, or 12 blocks per minute, it'll take her 2 minutes. And then 24 blocks in 1 minute, it'll take her 1 minute to get to her friend's house. All right, the last page. What happens to the time it takes to get to her friend's house as Meredith's speed increases? So the time decreases as she increases her speed. And then we can just say, if we're going to explain that or whatever, we could say the faster you go, the quicker you get there. All right. And that is the end of that lesson. Okay, do you guys have any questions?